Hello and welcome to this presentation. My name is Engineer Isaac Friday. In this video, you are going to learn how to model this steel bridge, load it, analyze, and design all of the structural members of this steel bridge successfully in this video. And so, you have to stick to the video and pay close attention for a better understanding of this complex modeling successfully. Once again, you are welcome and let us get started. We want to look at the parameters and the dimensions of the setting out of the steel bridge successfully. So I will navigate to the plan view, and then you can now see the setting out of the reinforced concrete columns and the foundations, okay, of this bridge. So our 1 meters spacing right here, okay. The bridge apart is 8 meters, alright. Then the total length there is 12 meters in the length aspect of it, and then in the width aspect of it we have the total to be 6 meters, which we have 1 meters, 1.4, 1.2, 1.4 and 1 meter, alright, successfully. So this bridge is meant to be constructed on land and not across a lake or a creek, okay. So we want to make progress into the modeling of this steel bridge successfully, okay. And also we are using Protastructure 2022 version, as you can see, right. So for us to start the modeling, we need to create a new project, okay. So we will click on the file menu right here and then navigate to new project. So this will open up a new project because you can see steel bridge x1, okay. So I will change that x1 to steel bridge 5, okay, just like this. I'll scroll down. I will be considering United Kingdom BS8010 for this modeling, okay, for the sake of the presentation. Click on OK options, and this will open up a template BS8010, so we can start the modeling aspect of the bridge successfully. Alright, so here the template is ready. I want to get to the building setup tab, and then you can navigate to the axis, okay, at the modeling tab rather, to the orthogonal axis. Click right there. You can pick any point in the scene environment, okay. So to have the orthogonal axis generator, okay, just as I used to say in most of the video, okay, I did on my channel, you notice the axis level A is the horizontal axis, okay. So for the axis level A, what we're going to have, because this is the horizontal axis, or the horizontal grid lines. You know, grid line consists of the vertical, okay, vertical grid lines, and then the horizontal grid lines, okay. So here we will have 1 meter, all right, just like this, and then we'll have comma. What we'll have next is 1,400, have comma. Have next is 1,200, have comma, and then we will now have 1,400 again, like this, we'll have comma, and then we'll have 1 meters, okay. So these are in millimeters, all right. So 1 meters is equals to 1,000 millimeters, okay. So we make progress in the direction to what we need to have. Also, we are going to be having, okay, so we are going to be having 1 meters right there. We'll have another 1 meters. So the space between the bridge, okay, is going to be 1,000 millimeters or 8 meters. We have comma right there, and we still have another 1 meters followed by the next 1 meters, just like this, okay. So we haven't gotten this. Just click on the OK option, and then you have this set out grid lines, just like this, okay. So you can now see we have total of 6,000, we have total of 12,000 this other way, okay. After which the next point is for us to generate stories, okay. We have to generate stories, and as well set our story height, okay. So we have up to 4 stories, so we have to select stories right there and click on the insert stories, okay. In these provisions we have 4 stories, all right. So you can see story height at default is 3 meters. We'll edit this later, okay. Click on the OK option, yes, options. So let's edit the stories, select the stories right here. Mind you, you can also get this option options through pass through the building set out, and then come to the stories operation, so you can see the same options. Okay, right? So we'll proceed and then click on the edit stories. So for the sake of the presentations, my story one is this going to be 450. So 450 in the sense that this is just like a normal 450 to the normal ground level. Okay, so my story 2 is going to be 1500. Okay, the first rest, okay, landing before you take up to this story. So to take up to this story should be like 2200. Okay, right, 2200, while these other stories we can't go by 2500 right there, or 2600. Okay, so this is the story set out. All right, then the structural systems at the foundation level, which is from story 1, is going to be ROC. Okay, so then from story 2 to story 4 is going to be steel right there, just like this. Okay, so the depth of the foundations in your calculations, you have to put this as part of the foundation depth, the 450 millimeters. All right, so right here we have 1100 millimeters as default foundation depth for that structure. Okay, then if you had this 1100 plus 450, you'll be having 1550. Okay, as the foundation depth for that structure successfully. For now, we will go by this successfully. Click on the OK options. Alright, so we'll start to place the pedestal, okay, by double clicking on the story 1. So here is the story 1. Okay, so let me navigate to the 3D so you can be able to see the difference between story 1 and the story 0 right there. Okay, but by then, to show you that clearly, you will need to be at the we will need to have some structural elements right here. So let's go back to the plan view. Right, so here we go. Now we get to the modeling tab. Okay, select the columns right there. So in the column dialog, we will be setting the column sections. Okay, we have it to be 450 by 450. Okay, we are going to try this actually. Okay, if it can be able to carry the bridge successfully. So now the first thing we'll place the columns right here. Okay, the first columns, we have another columns right here. So we have it as well here, and here we also have it here. Right, we just place this at random. We may correct this as we proceed. Okay, so we also have one here. We have another one just like this. Okay, so now this grid lines, this is the walkway. Okay, so be able to access this other landing of this bridge. Okay, this space between grid line D and C, while our landing as you goes up is the grid line E and F. Right, over to this side. Okay, to this other side is A and B is the landing successfully. Okay, so having placed this successfully, we will proceed to place our reinforced concrete. Remember, but by then let us navigate to the 3D so you can now see what we are having here. Alright, so we have this. So if you double click now on the story 0, you can now see this. So here is the 450. Okay, so 450 from the top of this pedestal to where the grid line is, and then from the grid line to the foundation depth, you have it to be 1.1 meters. Okay, so we make progress. Then let's navigate to that story 4 right there, where we're placing stanchions. Okay, so altogether, what should be the height of these stories? To know the height of the stories altogether, let's see it also here. This is 6.75. Story 4 6.75. So we have extensions that will cut through up to 6.75. Okay, this is the extension, so there's no problem with that. Okay, so we will get to the modeling tab. So we get to the column, but by then you have to navigate to the plan view right there. So you pick the column right there, come to the sections manager. We will be selecting the small sections. Okay, so we are going to use UB in this case, and then we use this one, 202.102.23 mm text. Get that selected, and then we will have it being protect, okay, 90-degree angle, okay, and then we are to have it here at this point. But by then here we'll have to key in tree right here, because update. Why I'm key in tree right there is because I wanted to connect all the stories, okay. It is a story 4, okay, so you key in tree, so you connect all the story. Click on update. All right, so once click on update, you can start to place it right here. So we have that, have this, and then we have this, okay, successfully. So the next thing is to place the stanchions over to this provisions successfully, okay. So let's check what we have done to ensure it is correct, okay. So it's supposed to sit on top of this. You can see sit directly on top of the pedestal. So this is what we have done so far. All right, so we make progress. Okay, so now you have to navigate to the story 2. This is where we have the first landing platform for this bridge. So you navigate as well to the beam provisions. So we'll be picking our beams right there, UB, and so we used 152, okay, 89 and 16 millimeters. Click on okay right there, and then we want to connect this successfully. So while connecting this, you have to be careful that you are picking the green line intersections to place this successfully. Right, so here is it. Okay, we are done with this. So over to this side, we will connect this as well. Okay, right, after which we would navigate to the next story, which is story 3. Okay, so at this story, this is where you can be able to now access the bridge, okay, access this other part of the bridge successfully. So we are going to be using this property, or we can also get back to the beams right there. Okay, so confirm the sections successfully. Okay, 152, okay, option, and then right, so that is done. Okay, we will get to the next story, okay, which is the top story. Okay, so you have to close this, navigate to the story 4. So at this story now, we will still get to the structural members, and we insert these beams successfully. So at this story now, we need to have a coverage, okay, a coverage in the sense that we have to have a cantilever beam right here, or have another cantilever beam right here, and connect it right there. Okay, so we have something of this kind. All right, so here we go over to this other side. We have to also have this. All right, just like this. Okay, so let's proceed. As well, you can join our ongoing training program if you have the interest to join. There's a link in the description of this video. You can just be able to reach us through the link successfully for the ongoing master training program for Protastructure successfully. Alright, so here we go. We have this. So the next thing we will be looking at, you notice we are supposed to have stair. Now this to connect this. successfully. Alright, so we will proceed to the foundation, so we can start to model the access stairway. Okay, so we have to now navigate to the story 1. Okay, at the story we need to move these columns to this point. Okay, grid line 2 from grid line 3, so you right click and then can select move. Okay, pick there, so you pick the point you want to move. Sorry, right click again, pick on move, and then take it to this grid line, just like this. Okay, so the same thing we'll be doing here. Okay, we move this to that point, so select it. Okay, and then you right click, can now pick move right here to this grid line successfully. Alright, so having gotten this, we will be connecting an incline member, steel members to form the stringer. Okay, but before then, let's do the same thing here. We're supposed to move these columns to this point. Alright, and over here, move this one. Sorry, move, pick these grid lines intersections. Alright, so we still get to the beams. Okay, this time around, let's check the sections. We use this one, 178, 102, 19 thickness. Select that. Okay, so we picked the first point and connect it to. Okay, escape that, close this first, and navigate to the story 2 right there. That story. Okay, then get back to the beams again. We will be using. Okay, that is it. Select okay, and then you make sure you pick the relay intersection right there. Take it down. We'll have something like this. Okay, for this first stringer, make sure you zoom closely and be able to pick the grid line intersections. The reason for the grid line intersections is for you to be able to get a good analysis result without errors. Okay, all right. Okay, so having gotten that, over to this side, we need to do the same thing here. Okay, so if you have any question, you can as well drop it in the comment section. All right, so having gotten this first, the next thing we'll do, we'll have to navigate to this level so as to model the steel member at that level completely. So at level 3 right here, we'll be having steel member. This, just use this property. Okay, we use this property, so we have escape that from that point to this point, and then from this point all the way here. Okay, so we'll be having a member here, after which we'll have another members that connects this point. Then we'll have another member so make sure, okay, it's at the grid line intersections. Okay, just like this. Okay, so we have something of this kind. Okay, so having gotten this, the next thing you have to do is we need to actually brace this. Okay, so we get to the modeling tab, but before then, save this project. press this right away, we'll be using the same members. This one, select it, right click the property. So we pick it from that point all the way to this point, intersection. It's not really giving us the exact point that you are supposed to place it, so you have to update this in a way that you can actually be able to view it correctly. So let's navigate the green lines to the story 2 right there. At the story 2, get back to the beams, check the sections is correct, select that, okay, then pick it right there, take it all the way to this point, place that. Okay, so you can see some warning right there. Okay, that's it. Current story 2, but ends of this beam is above the current story, right? So click on yes options, so you will now have this. Okay, so this is just what we intended. Okay, so proceed, pick that point. Okay, this is warning, it's trying to tell you you are inclining this beam. Yes option. All right. Okay, so having done this successfully, we proceed to this other side. Before then, you have to navigate to that story 2. So select the structural members. Well, you can't be able to mirror all of this to this other side. Okay, you can be able to mirror that. All right, but for us to be sure of our modeling system, our modeling is correct, I will advise you do it. You do it individually instead of modeling a group. Okay, do it individually just like this. Okay, so we will be having a member here, and we will have another member like this here. Okay, so for this side, when we use this member, select it, right click and click on properties, click that point all the way. We may not be able to get it like this, so close this and move the green lines to the story 2 right there, just like this, and then we use the same member, its property. So now we can be able to select the green line intersection successfully, and then all the way to this point of intersections. Yes options, have that successfully, and then from this side, pick that point. Yes options. Okay, so you can see what we have here, right? So having gotten this, now we'll come over to this side to do the same thing. Alright, so the same thing is applicable to this other side. So we proceed to the next stage. So the next stage, we will be considering the reinforced concrete slabs right here. Okay, so we are going to be using ROC slab to actually transfer the humans load to the beams, steel beams members successfully. So for you to do that, we are at level 2, so you just have to navigate to the plan view. This plan view, you have this. Okay, so select reinforced concrete slabs. Yes options. So we have to generate the loading successfully. Click on OK, and then now the slab dialog will be using 150 millimeters slab thickness with a cover of 25 millimeters. Okay, for an additional load, there is not much additional load, but we also use 1.5 additional loads. Okay, and then for the imposed load, Right, we will consider 3 kilonewton per square meters right here. So we have to place that here to have the reinforced concrete slab right there. So we place another one here as well. At this level, we are okay. So we navigate to the next level, which is going to be level 3. Double click on the level 3. This level 3, we still navigate to the reinforced concrete slab 150, 1.5, and then we use 3 kilonewton per square meters, because here we have a slab here, and we have it. Sorry, this is supposed to be across, okay, not only dot provision, so we can get rid of that by deleting it. So we use this property. Alright, so I notice it is actually trying to text the grid line. So this is being region selected. Okay, alright. So we can use another instruction option. So we can use pick point. We can pick that point. So there are various instruction options. Okay. So now change this back to beam region. Okay. So you have to actually decide you have your staircase, so you can place it correctly. So to do that, let's get to the 3D. But before then, we can't still get to the last floor, so we can't actually cover up this the sheet of the stairway successfully. Select the slab again. Right, so you have this successfully. Click on closed. Okay. When we are just using this, right, to actually send some loadings to the beams for design purpose. Okay, because at this level you may not necessarily have humans at this level. Okay, but we are actually using it to design the structural beam members, just as I said earlier, for the sake of unforeseen circumstances. Right, so we navigate to the story tree right here. So at the story tree, we select this, right click on property, and we have this. Okay, so when you land here, you have to follow this access stairway to land here, and then come over here. So here is Revit modeling the steel bridge beam system or truss system across. Okay, shortly we'll do that. So we'll also have to place the slabs as well here. Sorry, that is wrong. Supposed to put it here. So just make sure that great. So we'll delete that other one successfully. So we will also have it here and here, right? Same thing applicable to this provision and this. Okay, okay, this is showing me, okay, meaning you have to use another instruction option. So this time around, let's see how we use pick axis option. Okay, that options we need to pick axis B, right? See, it's showing here. All right, so pick axis 4, okay, axis A, and then axis 6, right, and B to place it. You can see it's being placed successfully. Click on closed. Okay, so at this point you can see the slab, okay, in an opaque option or format. You have to go to the building setup like there. Okay, click on the layers. So in the layers, you navigate to the slab options. See ash right there. So change this a bit to more darker color options, and then click on okay. So have it just like this. Okay, So you can see. Alright, so at this time we want to start to model the steel bridge members. Okay, the bridge between these two structure. Okay, let's proceed. Here is the full model of the steel bridge successfully. Alright, so for the video that explains this part of the bridge modeling, the link to get the video is in the description of this particular video. So check the description of this video, you will see the link, okay, that fully explained this part of this bridge modeling successfully. And this bridge is going to be constructed across the road, an expressway. Okay, so subsequently we'll be looking at foundations of this bridge. Alright, but for now this has not been analyzed, so we need to carry out the analysis of the steel bridge successfully. So to do that, we navigate to the analysis tab right there. So build analysis, you click on the build analysis, after which you have to set your soil bearing capacity. So to set your soil bearing capacity, you get to setting centers right here, and then you navigate to the foundations. And the foundations over here, a level stress of soil, we take it to be 100 kN per square meters right here. Click on the OK options, and the next thing you do is to set your material. So we will be going by this materials settings right here successfully. So after which we navigate to the analysis tab right here. Click on the building analysis. So we are going to be observing the analysis process. Okay, but by then, if you want to analyze and after which design the whole of the structural members, you have to have this provision check. But we want to analyze only, we will design the structural member as we proceed. So click on the building analysis. So we want to observe this analysis to see if there will be any warning in the process of analyzing the whole structural element of the steel bridge successfully. Alright, so our analysis of the steel bridge is completed. The relative story draft satisfies limits in both direction 1 and 2 successfully. So click on the OK option. So after which you proceed to view the post analysis. By going to the post analysis, so you can as well display the analytical model. So let us look at the analytical model. So if you click in these provisions once, this is going to load analytical model for us. So you can see the analytical model just the way it is. Okay, we want to check the animations, okay, based on the dead load on the structure. You can see it right here. Based on the live load, if you click here, live load, you can now see that. Okay, so here is the analytical model of the steel bridge successfully. So let's get back to the 3D model. Let's stop there animations. So we get back here. So now to design the members, you can as well start from the foundations pedestal right there. So we are on story 1, select this column, right click, and then click on ROC column design active story. So this will actually take us to here. Okay, so click on the bash mode, column design bash mode. We select all bars, click on calculate, and then close this. So this has been now designed. You can see the statute right there, and then the utilization ratio. There's no more stress at all at the foundations. Okay, so you close this right away. So you can also, I will show you how you can check the steel stanchions members design status. Get it selected, right click, and then you can now proceed to the steel members design. So once you click right there, you can now see we have all of the steel member designed successfully. The U ratio is 0.3, okay, less than 1, which has passed design successfully. Everything is good with the structural members of this steel bridge successfully. Alright, at this point we can now proceed to design foundations of the steel bridge successfully, which we'll be looking at that in the next presentation. So if you want to get the Protek file of the whole of the steel bridge model. You can download it through the link in the description of this video as well. Okay, so in the next presentation we'll look at the foundation design of this bridge when it's to be built on the land, and as well when it's supposed to be constructed across waterway. So thank you for staying through these presentations. We'll be stopping here. Don't forget to like and subscribe. Stay tuned. So each time we upload a useful content of this kind, you get alerted. Stay safe and God bless you. Bye for now.